Hey everyone. We're going to look at today a little more complex trig equations on lesson 2. And yes, we've returned to the workbook again. So we're going to be looking at now second degree trig equations, which really means the exponent on our trig ratio could be a 2 essentially. Okay, so that's the idea with second degree. And we're going to be looking at more trig equations later on in the unit at the very end, and that will be covered in lesson 8, where we're using identities. Now those get fun, I gotta tell you, but we're using identities to manipulate the equations first and then solve them. So we have that to look forward to, everyone. Those of you who love this stuff, you'll love that. Those of you who don't, yeah, not so much. Okay, so first of all, factoring trig expressions, okay? Not really a question you're going to get on my test or the diploma. However, it does help you in the process of solving trig equations. So I'm just going to go through a few factoring techniques to refresh your memory on example 1 here. Okay, so first step in factoring, okay, is always greatest common factor. You always look for the greatest common factor, okay? Then second step would be to look for one of your particular types of factoring, okay? So I'll just write down a few of them here. One would be, say, difference of squares. Okay, so if you have something squared minus something squared, that could be factoring difference of squares. One would be factoring a trinomial, kind of in this form where the leading coefficient is a 1, or one could be factoring a trinomial where the leading coefficient a is not 1. Okay, and those are a little more complicated. And again, we reviewed these earlier. Then another possibility would be if you have 4 terms, which we don't have any on these examples, you do factor by grouping, okay, to factor that. If you're going, what is she talking about? You might want to go back and review that lesson on factoring from the very first unit that we did, okay? Because really we're doing the same thing, it's just now trig functions. Okay, so let's look at the first one. We have 8 tan A, okay? First of all, let's talk about this. This inside here is part of the tan. So when you look at this, you should look at that as all one thing, okay? So we have 8 tan A plus 4. We have a greatest common factor of 4. So yes, we could factor 4 out, and we would have 4 and then brackets 2 tan A plus 1. Okay, that tan A is, you know, like having something like M, okay? Same idea. All right, here, let's take a look at this. Now, sine squared x, I'm just going to write that in a slightly different form so that you can kind of picture what's going on here. It's sort of like having that. So in other words, if you had, say, something like y squared minus 3y, what would you factor out of that? Probably a y, right? So here, what would you factor out from these two terms? You would factor out sine x because it's common. When you divide it out of the first term, you'd be left with a sine x, right? Sine squared divided by sine. And when you factor it out of the second term, you'd be left with just the minus 3. Okay, and there you go, nicely factored. All right, so let's look at C now. All right, 4 sine squared minus 1. I'm not sure I would factor this for a trig equation, but this is a difference of squares. 4 is 2 squared, sine squared is sine squared, and 1 is 1 squared. So 2 sets of brackets to do a difference of squares. The first term in each bracket is the square root of the first term here. So 2 sine x, and write 2 sine x here as well. Check it. 2 sine x times 2 sine x, 4 sine squared. Good. Okay, square root of 1, 1. Okay, and with opposite signs, we would then get the outside and the inside terms to cancel if we expanded it, hence giving us only the 2 terms from multiplying first and last. There you go. That's your factored form. Okay, let's take a look at this one. Now, when it starts getting into 3 terms, hopefully there you recognize, hey, I've got this kind. Oh, actually this kind, type B, 1x squared, because there's just a 1 in front of my squared term, plus bx plus c. In this case, people really find it easier if you say let say cosecant, okay, cosecant x equal, pick a different letter, any other letter but x, like any other letter but what's inside. I like to choose m because that doesn't usually come up as an angle inside. So this would mean that this could be called m squared. Remember, cosecant squared is sort of like cosecant in brackets squared. So now that would just be m squared, right? Okay, so let's just write that as m squared minus 3m minus 28. Okay, now you recognize it, right? Yeah, for sure. Okay, two sets of brackets. What multiplies to m squared? M and m. What multiplies to 28? Well, quite a few things, but we have to have then the difference, because this is a minus sign, the difference of those two numbers would then equal negative 3. Okay, if you can't think of it right away, be methodical. 1 times 28, nope, difference of 27. 2 times 14, no, that's a difference of 12. 3 doesn't go in, 4 does. 4 times 7, 4 and 7 have a difference of 3. There we go. So put your 4 in, put your 7 in, don't worry about the signs yet. We know they have to be different signs based on that negative 28, and we want to end up with a negative 3, so our bigger number is going to be negative. And there we go. Now that we have that, let's put cosecant back in for m. So cosecant x plus 4 and cosecant x minus 7. There we go, nicely factored. Okay, now next question. Okay, these ones are the most fun. All right, just kidding. We have 2 cosecant squared plus 7 cosecant x minus 4. Notice we have a cosine, did I say cosecant? Sorry about that. We have a cosine squared plus something cosine. So we have this kind, type C, happening here. So again, let's replace so it's easier to look at. Let m equal cos x, and this would become 2. And again, cos squared is just cos squared, right, in brackets. So this would become 2m, we replace cos x, squared still there, plus 7m minus 4. Okay, notice there's no x's in my line up here, so you shouldn't have them. Okay, so we have that. We have a number in front of our m squared. So however you factored this or found a way that you like to factor this, I like to do that funky weird method, which is, okay, first of all, we're looking for something that multiplies to negative 8, 2 times negative 4, and adds to negative 7, or positive 7. So we do the two sets of brackets. We go 2m and 2m, right? That's the funky part, because 2 times 2 does not equal 2. So we have to balance it off by dividing by 2. Okay, then two numbers that multiply to negative 8 have a difference of 7, would be 1 and 8. We have to end up with a positive 7, so the 8, the bigger number, is positive. Okay, the other one will be negative. And then we divide this 2 into whichever factor it goes into. Can't go into the 2m minus 1 because it's not common to the 1. But here, 2m plus 8, that's sort of like saying 2m plus 4 if we factor out the 2, and the 2's can go. There we go, we're left with 2m minus 1 times m plus 4. Oh, but we weren't working with m's, were we? So it's 2 cosine x minus 1 and cosine x plus 4. And there we go, nicely factored. Okay, let's take a look at our second example. Solving a second degree equation using a graphical approach. Okay, so yes, you can solve these graphically, okay, which is really great news. You can even give your answers as exact values, which I'm going to show you how. But if on a question, a written response question of mine, I say use an algebraic approach, this would not be given any marks at all if you did it this way. Okay, but where would you use this? Multiple choice questions, okay, for sure. Or if you numeric response questions would work as well. Or if you just want to check your answer because you did it with written response. Okay, so it says use a graphical approach to determine the roots of the equation where, here's they're giving you your domain. You know what that is? Your x min and your x max when you do your window settings. Okay, and then your x scale, I don't know, doesn't really matter. You can put it as pi over 6 if you like. Okay, give solutions as exact multiples of pi. I'll show you how to do that. To solve this graphically, you're going to put the left-hand side in y1 and the right-hand side in y2. Okay, but I have to tell you, to enter a squared function in your calculator, you have to be very careful with that. So I'm going to show you how here. You're going to put a 2. Then to square this properly, you're going to go bracket, or sorry, yeah, bracket, sine, and then you're going to put the x, and it automatically throws a bracket in around that, and then you're going to square it. Now, if you have one of the newer calculators, you might be able to just go sine and then exponent squared, but take note of where they put the square when that happens. Is it on the x, which would be wrong, or is it on the sine? Okay, if it's on the x, then you're going to have to do it this way that I've shown here. Put brackets around the sine, square on the outside. Okay, y2 is going to be the other side of the equation, the right-hand side. So left side goes in y1, right side goes in y2. Okay, and where do you think the solutions are going to be? Yep, the solutions will be the intersection points. Okay, so let's throw that in the calculator. I'm going to bring mine up. You can as well. Okay, so notice what I've got plugged into the calculator here under y equals. We have 2 bracket sine, and see how it automatically put that bracket in? X, which you got from the xt theta button, end your bracket on the sine, end the bracket, or on the angle I should say, end the bracket on the whole sine, and then hit the squared button, this squared button here. And then y2, 1 minus sine x. Okay, check your mode. What mode do you think we should be in? They gave us a domain from 0 to 2 pi, I believe. So we should be in radian mode. If it was 0 to 360, we'd be in degree mode. Okay, window settings. Okay, so really bad window settings for plotting trig functions. A good start on this would be just to get a graph, so you have it showing up, is go zoom trig number 7. And there we go, our 2 graphs. Now let's go back and modify our window settings. We wanted a window setting of, yes, it was 0 to 2 pi. I just had to check that a minute. So we want to put 0 in x min and go down and put, that is actually 2 pi, well close to it, but we'll just make that a little better by going 2 pi. And there we go. Okay, don't care about the scale, doesn't matter. Y is probably okay, but it looked like we didn't really, if we look at this graph here, we don't need anything below the x-axis, so let's maybe make our y min like -1. Okay, and y max, just looking at the graph here, could probably be 3 if you really wanted a pretty graph. Everyone want a pretty graph? There we go. Okay, so our solutions is where it crosses. All right, how do we find that? We go second calc, intersect, number 5. Don't have to scroll down, just hit number 5. And there we go. It's asking for first curve, so hit enter. Second curve, hit enter. Then focus on where you want to actually find the solution. So for guess, we're going to have to go left. I'm going to get the, oh yeah, this is going to take forever. You can just sit here and listen to me tap. Isn't that pleasant? Okay. Alrighty. Okay, so guess. As long as you're close to that first intersection point, hit enter. It should find it. And there we go. Look at that ugly number for x. So how are we going to get that as an exact value? You know what's going on is we're in radian mode, and that number has pi in it. And of course, it's not going to be a nice number as a decimal when it has pi, because that's irrational. Okay, so what we're going to do, here's what your calculator just did. It just stored that number in x for you. So if we quit out of here and we go x, enter. Hey, there's that number again. Cool. Okay, let's take pi out of it. Okay, pi is making it messy. So let's divide it by pi. Oh, that's nicer, I think. Let's math fraction that. Math, enter, enter. 1/6. So hey, guess what? That one was actually pi over 6 was our answer. Okay, so you guys go ahead and find these other 2 intersection points. I got to warn you, this last one is going to be a little bit tricky. You're going to get approximately the right answer. So you'll have to use your best guess on the calculator for that one. And then write your answers down, okay? And so yeah, pause your video, please. Hey, welcome back. So I imagine you might have had some problems with that last intersection point, and that always happens when you have one graph basically just coming up and touching the other graph. It doesn't really cross it. So your calculator kind of has a nervous breakdown regarding that. So when you divided pi out of that intersection point, you would have gotten and you might have gotten 1.5001 or something like that too. What you have to do is use your add here. 1.499